Okay. Both the volume and the surface area of a cone or of a sphere are in your formula packet. So we don't even have to think about a net for a sphere because the net for a sphere is actually super difficult. Think about a globe, the world, right? And how we've taken the world, which is a spherical shape, and turned it into a flat surface for a map. The map that we see on when we see it in a two-dimensional shape is really distorted. Take a look at the poles, right? Look at Antarctica or on like the North Pole or any of those guys, or look at Greenland as you're going further up. On a two-dimensional map, it looks crazy and huge and spread out. But if you look on a globe, it's actually a lot smaller than it looks on a two-dimensional map. Taking a globe and turning it into a two-dimensional shape, which is what a net is taking a three-dimensional shape and showing it in two dimension, the net is weird. And we don't see maps in that way because of the fact that the net is weird. So let's just talk about the formula real quick. One of your fellow 11th graders is doing his extended essay on how to do a net of a sphere, basically. Okay, so volume. We can talk about why it's 4/3. It is related to why a cone and a cylinder are a third relationship. With spheres, it's different, but that's where the third comes in. But it's 4/3 pi r cubed. A very common mistake is that you will do squared instead of cubed on the r because we're so used to the squared with area, but just try and remember it's volume, so it's going to be cubed. All right, and then surface area for a sphere is 4 pi r squared. Area squared, volume cubed. So that's how you can remember both of them. Check mark, are in your formula packet. Okay. Cylinder. I'm just looking at your formula packet real quick to see if it's there. It is. So the volume of your cylinder is in the formula packet. It is the same as any prism because a cylinder is just a circular prism. The volume of your cylinder is the area of the base times the height. The area of your base is pi r squared times your height. So I think in your formula packet, it's pi r squared h, where r is the radius of your base, and it's just the area of your base times your height. That is in your formula packet. The surface area. If I were to make a cylinder, taking a piece of paper, I would just roll it up to make it look like a magnifying, what are these called? Telescope. So this is how you make a cylinder. There's two bases, right, that are the same size. You've got a circle here and a circle here, and those are the same size. So taking apart all of your pieces that make up a cylinder, you've got two bases that are the same size, and then you've got this lateral area. The lateral area, if you were to unroll it, is just a rectangle, such that when you roll it up, the top of the rectangle is just the circumference of your circle, and then the height of your rectangle is just the height of your cylinder. So it's the circumference of the base plus times the height of the cylinder in order to make the lateral area. So drawing the net, because surface area, we have to think about it as a net. A very poorly drawn net, but you've got two circles and then you've got that rectangular surface. Okay, so surface area is going to be 2 times the area of the base, keeping in mind that with prisms, you've got two bases and they are equal in size. And then you've got the area of the curved surface. Again, your formula packet calls it the curved. surface. Now, this area of the curved surface of a cylinder is in your formula packet. It's in the very beginning of your formula packet as opposed to in the middle of your formula packet. You should definitely be trying to have your formula packet out and look at where these guys are. Your formula packet should be a friend to you when you go into the IB exam. You should have this and know this front and back. Know exactly where the formulas are. Know that when you get to a problem, you're like, oh, I know that's in the formula packet, or oh, I don't. I need to know this. It's not in my formula packet. Anyway. So looking at your formula packet, the area of your curved surface is pi r squared h. Sorry, 2 pi r. H. So r is the radius of your base and h is the height of the cylinder. Because remember, as we broke it down with the piece of paper, the one length, finding the area of a rectangle is base times height. The base is the circumference of your circle. Circumference of circle is 2 pi r. And then the height of your rectangle is the height of the pyramid or prism. Cylinder. All right, so that's this guy. And then 2 times the area of the base is 2 times pi r squared. Now, this whole formula is not in your formula packet, but this guy, the area of a circle, is in your formula packet. This guy, the area of the curved surface, is in your formula packet. So try and find a way to tell yourself the whole thing is not in your formula packet, but each piece is. And so as long as you can understand the idea of breaking down these 3-dimensional shapes into smaller 2-dimensional shapes, then not smaller, but breaking it down into 2-dimensional shapes, then you're good to go in terms of finding those guys. Okay. Volume of a cuboid is what they call it, which is a rectangular prism. So the volume is just all 3 dimensions multiplied together. This is your base, length times width times height. So L times W times H. It is in your formula packet. It's one of the more straightforward ones. It's at the beginning as opposed to in the middle. Surface area. The surface area here is going to be, I'm going to draw out the guy. Okay. So if we have the base, which let's call this L and let's call this W, then we've got rectangles coming out from either side where this guy is W, but now think about those guys as folding up. This guy right here is H. And then we've got L, and then this guy has to be H. Think about those 2 corners folding up onto each other to make the corner of the prism. Maybe think about it from that direction. So that's L times H, and then this guy up here will also be L times H. And then, so that's, try and think about it. All 4 of those guys would fold up from the base, and then we still have to talk about our second base that's up there. And I might just attach that down here, where this is still L, but now we have to talk about this is L times W. So notice here, we've got these 2 rectangles that are equal. We've got these 2 rectangles that are equal. And then we've got these 2 rectangles that are equal. I'm just checking to see if this is in your formula packet. I don't think it is. Let me go down to the second one. It is not. So this is probably one of the ones that you might struggle on memorizing. So I would recommend understanding the net of this guy. Or try and find a way to help you remember how to piece it all together. But your surface area is going to be 2 times length times width. So the area of that rectangle multiplied by 2 plus 2 times height times width plus 2 times length times height. So it's all of the different ways that you can multiply the different dimensions, which is 3. And then there's each of those dimensions multiplied by 2, because if you think about it, your opposite sides, your opposite faces of a rectangular prism all have to be equal. So that's your surface area. It is not in your formula packet. Okay, we have another prism here. It works exactly the same as our last 2 prisms. We've got 2 bases. They just happen to be triangles. And then we've got the rectangular surfaces around. The volume of this guy is going to be 2 times the area of the base plus the area of the rectangles. None of this is in your formula packet. Oh, sorry. I was thinking surface area. So sorry. Volume, like with your other prisms, is area of the base times the height. Here, the height is L. Notice that L, the height of our prism, is not actually tall like a height would be. It's been laid on the ground. But so the height is really the distance between our 2 bases, and our bases are triangles. Our bases are what determine the shape that it is, right? The bases of a cylinder is not the curved surface, even though you can lay a cylinder. I was about to take my coffee mug and do that, and I realized there's coffee in it, but here, right? Like the base of this guy is circles, but I can still lay it on its side and the base is still the circle. It's not now this bottom piece that's laying down on it. So with cylinders and with triangles, triangular prisms, the base is the shape that makes it this, right? With rectangular prisms, it doesn't matter because all of them are deciding factors of what makes it a shape. They're all rectangles. So it doesn't matter which one's the base. With other ones, it does. With triangular prisms, with cylinders, if you have a pentagon as the base, you could have a pentagonal prism. The pentagon would still be the base, even if it's laying on its side. So here, L is the height. Even though it's not going up and down, it's the distance between the 2 bases. So in this case, H equals L. Not in your formula packet.